Hey YouTube, welcome back. Today we continue our course in system design. Today we'll talk about the message queues. Um, and the message queues actually are a communication mechanism that used in distributed systems and software architecture to enable asynchronous communication between different components or services, and it allows one part of the system to send message or tasks to another part without the sender and receiver needing to interact with each other in real time. A message queue providing several benefits for building scalable applications like decoupled and design systems. And let's just see how they work, because they will look quite simple. Um, and yeah, let's just make it white and like that. So we will have like a producer. And the producer is a component or server that creates and sends the messages to the message queue. Okay. And the producer will connect with the actual message queue. And here a message is a packet of data that contains information or tasks to be processed by a component or service. Messages can be various formats such as JSON, XML, or binary data. And we have right now the consumer. And the consumer is a component or service that reads messages from the message queue and process them. Maybe we could have multiple consumers can read from the same queue concurrently as well. We have also the queue. This one called the queue, and the queue here, a queue is a data structure that stores messages in the order they were received. Message are typically processed in first in first out manner. And we have something called a broker. And a message broker is a middleware service responsible for managing message queues. It mediates the communication between producers and consumers, ensuring reliable message delivering, and often providing additional features like message persistence, routing, and transformation. The benefit of using the message queue, first, we enable the asynchronous communication. So basically, the producer and the consumer are not connected with each other anymore. They use the message queue to connect. And this one, the message queue, enables asynchronous communication, allowing the producers and the consumer to operate independently. This decouples components and reduce dependencies, making the system more flexible and scalable. So basically, the consumer is not rely on the producer anymore. It just waits for any new tasks that have been shown in the message queue. Also, it has a benefit in the reliability. The message queues ensure reliable message delivery. If consumers fails to process a message, the message remains in the message queue until the consumer successfully process it, and this prevents data loss and guarantees message delivery. It's better for scalability. So basically, the message queues facilitate horizontal scalability. You can add more consumers to handle increased message loads without changing the existing infrastructure. It's also good in concurrency. So basically, multiple consumers can process messages concurrently, which can improve the throughput and reduce the processing. So basically, we have like maybe more than one consumers, and let's right now we have add more consumers, and all of them could take the messages from the message queues. We have the fault tolerance. Messages queues are often designed to be highly available and fault tolerant. They can replicate data across multiple nodes or data centers to ensure continuity in case of failure. We have it's better in distributed systems. Like message queues are fundamental building block of distributed systems, helping coordinate activities between distributed components and services, and also it's good for logging and auditing. So message queue is serve as a log of activities, making it easier to track the audit system behavior. So in this case, let's see how we will add the message queue to our own system right now. So we have this system, and let's just to copy it here, and we want to add the message queue. So the message queue, most of the times they being connected to the web servers. So we will just take here and we could add like I want to make it like that. Yeah. And can we make it like I want a different color. Yeah, no. Okay, and can I get like and exactly, and this will be the message queue, and it will be responsible for handling the asynchronous communication. No, sorry. And let's just go up. Let's make it quite wider. Okay, and let's copy this one and add it here, and I guess it will be no. And yeah, that's it. So basically, let's talk about the use cases for the message queue. That you could use this message queue with a web server. So you can use it like at a task queues, like a message queues, or commonly used in task scheduling system to distribute and manage background task jobs. We can using in the event-driven architecture. So in event-driven system, message queues facilitate communication between event producers and consumers. We can use it also in microservices communication. So microservices architecture often rely on message queues to enable communication between loosely decoupled services. We can use it also in data ingestion. So basically, ingestion. Sorry for my pronunciation. So basically, message queue can be used as for ingesting and processing data streams in real time and analytics and data pipelines. We can use it for order processing, like the e-commerce platform used message queues to manage orders processing to ensure orders are processed in the correct sequence. You could use also like a popular message queue system and broker include Apache, Kafka. We have like AWS, SCQS. There's a lot of things that you can use for it. So that's it for this video, and I hope you like my content. If you like my content, make sure to subscribe and hit the notification bell so you'll never miss a video, and see you in future problems.